16.12, inferences from a velocity graph. So we're going velocity, trying to antiderive it or integrate it to get the initial position, or knowing about velocity, or maybe even acceleration. A particle moves along the x-axis for a time of 0 to 18, such as its velocity is given by the graph below. What is the average rate of change of the particle's position on the interval from 8 to 12? So this is the only x values we're using. Remember, position then is called x of t. If we're wanting the average rate of change of something, that's simply the slope. And slope formula is m equals y2 minus y1, or I'd say x of 12 minus x of 8 divided by x2 minus x1, or 12 minus 8. So I'm going to have to find what the initial positions were, what the y values were of this point, so I can plug this in. So really what I'm doing is integrating or anti-deriving from 8 to 12 of my velocity graph, which I know simply means find the areas in that region, and that'll give me what I need. And then I'm going to have to divide by 4, because 12 minus 8. It's kind of like finding the average y value. Okay, so 8 to 12. 8 to 10 makes a triangle. And 10 to 12 makes a triangle. We've got 2 times 5 is 10. Half of 10 is 5. 2 times 5 is 10. Half of 10 is 5, but it's negative. Ooh, look at that. So those are the exact same size triangles. They're going to cancel each other out to make 0. So 0 divided by 4 is 0. So that's the average rate of change. Let's try a couple more. Number 2 is asking us to find the displacement of the particle. So again, displacement is really netting or finding the difference in the original values, x of t. Displacement always makes me think of the water in a bathtub, you know, when it's full, but then you get in it and it's even fuller. Displacement is finding the difference. So we want to really anti-derive from 0 to 8 of the velocity graph. So just find the area. We can do 0 to 7, and we'll have to do 7 to 8, it's a little one. We've got 7 times 4, 28. Half of 28 is 14. This is a 1 times 2, which is 2, but that's going to be half of that's 1. So we really got a 14 and a negative 1. So really its displacement is just 13. Number 3, they want us to find the position of the particle when it's farthest to the left. That means that we want the smallest y value when, you know, we got to find x of t. So the position, we got to really just find the minimum, kind of like we were finding the maximum on the other lessons. So we'll have x, which is really a t, and then x of t. And we're going all the way from 0 to 18. And so we'll go 0, we'll do our critical values, 2, 7, 14, 18. And it tells us the initial condition that when time is 0, particle was at 1. So from 0 to 2, just find area. 4 times 2 is 8. Half of 8 is 4. So we're going to add 4. So at least I'm going in the right direction every time. 2 to 7, that's 5. Times 4 is 20. That's negative 10. 5 minus 10 is negative 5. 7 to 14, that's a base of 7. Times a height of 4, that's 28. Divided by 2 is 14. That's 9. And then we've got 14 to 18. 4 times 4 is 16. Divided by 2 is 8. So negative 8. 9 minus 8 is 1. So the smallest number I see is negative 5. And it just wants the position. So we'll put that. If it would have said, what is the time when it's at the farthest to the left, you would say it's 7. All right, and last one of these. Particle moves along the x-axis. There's its velocity. Find the total distance traveled. Total distance is going to be just adding up all the absolute values of x of t. Because velocity gives you a direction, but we don't care if we're going left or right. We just want to know the total distance. So really we're taking the integral from 5 to 9 and we're doing v of t, but it's got to be the absolute value of it. Okay, it's also like thinking everything that's below here is being reflected so that we can find the total area. So you think of that too. Okay, so if I split this up and go from 0 to 2, that would be 2 times 4 is 8. Half of 8 is 4. Plus, this would be 7 times a height of 6. Not 7, sorry. 5 times 6 is 30. Divided by 2 is 15. This triangle is 7 to 12. That's 5 times 6, another 30. Divided by 2 is 15. These don't quite look the same size, but I guess they are. And then 12 to 18, that's 6. Times 4 is 24. Half of that's 12. So if you didn't want to think of them all being up here, just find the area. So even though that's negative, it's the absolute value of that. And it's the absolute value of this 15 here, which makes them positive. So 4 plus 15 plus 15 plus 12 would be 30. Plus 12 would be 42. Plus 4 should be 46. So that is the total distance. Whether it went right or left, we don't care. Total distance.